up to do, we're combining two things that we've learned before, our stoichiometry and our yield. And yield, you might be learning about yield in driver's ed with the traffic sign there. Yield in a driving context means to let somebody else have the right of way, to be cautious at an intersection. Yield in a chemistry sense means how much product do you get out of a reaction? Okay, what do you get out of it? That's also how yield is looked at. Okay, so what we're talking about in these is what is my percentage of product do I get? Now, in reality, there are three types of yield. There's actual yield, theoretical yield, and then what we intend to calculate is percent yield. Okay, actual yield is essentially real world. Okay, so actual yield is, hey, we do the experiment and this is what we get in the real world. Theoretical yield is what we do on paper. In a perfect world, okay, I would get this much. So it's whatever the balanced equation tells you should be made. It's the answer that you get from your stoichiometry problems. So the pages of stoichiometry problems that you've been doing, okay, that's actually every single one of those up until now has been has been theoretical yield. So every single problem we've done now has been theoretical yield. Now, in order to get actual yield, you've got to do two things. You either have to do the experiment or be told the information. So since it's just a short explanation, I'm just going to tell you the information. And then in order to do my point here of this lecture, percent yield, this is what I do. I take the actual yield, divide it by the theoretical yield, multiply it by 100, round for sig figs, we're all good. Okay. So percent yield will tell us how efficient a reaction is. Percent yields cannot be bigger than 100%. Sort of. Okay, so they sort of can't be bigger than 100%. The idea is that you can't have greater than 100% because you don't want to violate the law of conservation of mass. So the law of conservation of mass, which we've talked about in this unit and others, is what you start with is what you have to end with. Okay, the mass you start with is the mass you have to end with. So theoretically, you can't have a percentage greater. You can't end with more than what you started with. We can't create matter. It's always conserved. In reality, you do on occasion see percent yields of greater than 100% because sometimes people made an accident. There's contamination and they actually accidentally put extra in there. Okay, so it can happen, but theoretically not so much. So here's the example we're going to work. 6.7 grams of copper is produced when 39.2 grams of aluminum are reacted with excess copper to sulfate. So if you've already watched the limiting reactant one, we know this is an excess. I'm not worried about it. Okay. And I am starting with 3.92 grams of aluminum. And when I do this, I get 6.78 grams of this copper out of it. Okay. This right here, it says is produced. Okay. This is my actual yield. I did this in real life, and this is what I get out of the experiment. Is the 6.78 grams. Theoretical yield is going to be our stoichiometry. So let's break these down. Okay, so I already showed you that the 6.78 grams of copper is my actual yield. 6.78 grams of copper. Well, what's my theoretical yield? So in order to get the theoretical yield, I need to do stoichiometry. So here's my starting amount. 3.92 grams of aluminum. So I'm going to do my stoichiometry, 3.92 grams of aluminum, and I'm going to see what it is in terms of copper. So grams of aluminum to moles of aluminum. Okay, diagonal down, moles of aluminum to moles of copper, which is what I'm looking for, my mole ratio step here. diagonal down, moles of copper to grams of copper. So start filling in the numbers. I've got moles and grams, so moles gets a 1. Grams comes from the periodic table, 26.98. I've got moles on top of moles. That is my coefficients for my balanced equation. So here's moles of copper, 3, and moles of aluminum, right here, 2. And I've got moles and grams again, so moles gets a 1, and copper off the periodic table is 63.55. I do my calculations, and I get 13.850 and some more numbers. I went around for sig figs. It looks like 3 sig figs is it. So 13.9 grams of copper. That's my theoretical yield. Okay, so in a perfect world, if I were to do this experiment, I'd get 13.9 grams of copper. But in all actuality, I only got 6.78 grams. So what's my percent yield? Okay, so again, percent yield is the actual, what did I actually get from the experiment, divided by what I should have gotten from the experiment, times 100. Okay, and I do that with my calculator, and I get 48.776, and again, some more numbers. If I take a look at my sig figs, I should need 3. So that would be 48.8% yield. Okay, so that would say that my reaction is about 48% efficient, or 49%, or, you know, I only get about half of what I planned for. Is that really good? Well, it depends on the reaction. You know, sometimes we can make that better. Sometimes we can get up to 90 or 100%. But in this particular example, just under 50%. Okay, so that's really all there is to percent yields. You got to find the actual yield. The only way you can get the actual yield is by either doing the experiment yourself or being given the information in the problem. You do a stoichiometry problem to figure out the theoretical yield, and then you solve actual over theoretical times 100.